Hello to everyone who is joining. It is the top of the hour, so we are going to get started. Welcome to today's webinar, How Slickdeals Accelerates Data-Driven Decisions at Scale. I'm Laurel Ackerman, Marketing Director at AtScale. Before we get started, just a couple of housekeeping notes. This webinar is being recorded and we'll send out the recording to everybody who registered after the event. We will also be opening this up for Q&A at the end. So just add your questions in the chat box at the bottom of the screen and we will take them at the end of the presentation. And we'll make sure you know how to get in touch with us if you have questions that arise after the webinar is over. Today, we're also going to have a short survey at the end of the webinar, so you can let us know what information you found most useful. So if you have a minute for that, we'd really appreciate your input. Okay, so today we're going to show you how to leverage a cloud data platform to extract maximum value from your data to support your business stakeholders. You're going to hear how Slickdeals has been able to provide dimensional analysis on over 8 years of data to their analysts and their experience adopting the Snowflake Data Cloud and replacing their legacy SSAS workloads. And then you'll see a live demo showing how you can leverage your existing analytics stack to improve a wide range of data consumption use cases. So I'll introduce today's speakers. We have with us Greg Mabrito. He's the Director of Data and Analytics at Slickdeals. Prior to that, Greg was part of the Big Data and Infrastructure team at HEB for over 15 years. And his career has been focused on looking for opportunities to find new ways to approach solutions. And Dave Mariani is here as well. He is a co-founder and CTO at AtScale. Dave's a big data visionary, serial entrepreneur. Prior to AtScale, Dave was the VP of engineering at Cloud and at Yahoo, where he is known for building the world's largest multi-dimensional cube for BI on Hadoop. So now let's get started. I'm going to hand this over to Greg to dive in. Thanks, Greg.
Thanks, Laurel. Appreciate the time. All right, so let's get started. For those of you that don't know what Slickdeals is, and if you're like myself, I only found Slickdeals only a couple of years ago. It's really the greatest little secret on the internet for deals and savings. So just to give you some background on what Slickdeals is and what we offer there. And we're now celebrating over 20 years of savings and deals at Slickdeals. And what the core to Slickdeals is really this social shopping platform in which the community provides deals and information on deals and products to the community. And so it's a really great platform in which you can get educated and learn about products and what you like, what others like and don't like. And the community and the platform itself is just a really great tool to use for shopping. So we hope folks go out and see it and enjoy the deals and savings there. If you go to the next slide. So what does Slickdeals offer and how are we connected? So we've got over 1 billion visits annually to our site or through the mobile app. And they're the #1 external referral of traffic to Amazon, eBay, and Walmart. So we deal with a lot of users, right? 12 million unique monthly users, and overall over 6.8 billion saved by all those users. So it's really, really high volume. And so we do this by providing the desktop experience, a mobile app, browser extension, the loyalty program, which is the cashback, the front page and popular deal sections, deal alerts, coupons, and editorial content. And so the front page is really where you see the best deals of the day that are going on right then and there. And the way that deals flow through the system is users vote on those deals to get them to the front page, or hot deals or popular deals. And so really the best stuff is on the front page. So when you go check out the front page on your through desktop or mobile, you'll see the greatest stuff that's on sale or has a deal for you. And if you're using the browser extension like me and you went to Home Depot and needed to buy some things, it automatically finds the coupons you need. or finds deals and cash back for you too. So pretty great products, and I continue to use them, and I know that lots of folks that I introduce Slickdeals to love the products. So hope you guys go out and check it out and download our products and use them too. I think you'll enjoy them. So a little bit more info about me and my team. I've been at Slickdeals for about a year now. We're really on a mission to provide the future data platform for self-service analytics, just pretty much like everybody else. We've got very high volume. Just this last year, we've had about 14 billion in footsteps traffic, which is our web and mobile traffic. And so we support all of these lines of business, all of these products and engineering with 2 data engineers and 2 data analysts and myself. So we're a horizontal team spread across all of these products. And this really speaks to the high caliber of the team, the technical know-how and their ability, and really the great company that we work at Slickdeals. It's a ton of fun. And by the way, we're hiring. We got lots of open positions too. And if you're interested in solving complex data problems, come talk to me. We'd love to have you on the team. So with that said, we'll move on to the pursuit of processing. I love this slide that you guys provide in all your webinars and how everybody changes over the years. What you can see here in 2012 is really when Slickdeals implemented their data warehouse with SQL Server and SSAS and SQL Server Analysis Studio and SQL Server Integration Services, all in one box. So that's when they've been collecting data in MySQL and other ways over the years, but 2012 is when they initially started the program. Really, Excel was the primary user interface, and used by accounting and product and finance. Nothing really wrong with Excel, and we like Excel, and everyone uses Excel on a regular basis. And we want to support a platform that is about bring your own BI tool, and having a universal semantic layer and a single source of the truth is key to us. So that's part of our platform, and we really love that. And as you can see, in 2012, we're on one physical server on-prem, and that was the deployment. And so that worked for a little while. And then in 2014, basically had to make some adjustments hardware-wise, capacity-wise, and move to a separate box just for the SAS cubes to really improve performance and user experience. And then in 2016, we had to grow that box. Had to get more capacity, had more users, had more data. And at that time, that's when we added Tableau to the mix for visualization, and Warescape was actually added as our orchestrator for SQL Server and ingesting data and moving data around. And then in 2018, the SQL Server hardware had to be upgraded again because we needed more capacity. So kind of a constant theme here over the years, continue to try and grow and handle more data. With the volumes that we have, continue to get more and more difficult. And really in 2019, we basically kind of pushed the limits of SAS. We were trying to store all of that data in cubes, and very typical for our users to drag a metric into a pivot and not put any filters on it. It would try and load everything in one shot like that. So user experience wasn't very good, or isn't very good, and that really kind of set us up for what the future held here in 2020 and the changes that we started to implement. And then you can see in 2020, a whole new architecture, a new data platform, utilizing Snowflake as our backend, AtScale as our OLAP cubes, visualization still with Tableau and Excel, and Warescape, we implemented their Snowflake adapter to move the data. And then we also started implementing some Kafka to start working on our event-driven architecture and get and really move the needle as far as data latency. And we're really changing and refactoring all of our data pipelines to be event-driven and to populate our data store. And so that's really, in 2020, we started this migration, and we're not just doing like a lift and shift as quick as we can get it into the cloud. We've been looking at modernizing the platform, looking at what exactly we need for our business, and customizing that to meet the needs. And so moving to event-driven architecture is a big part of that also. All right. So I want to go through the year of change. So 2020 was a big year of change for a lot of reasons, but here at Slickdeals, we made some major changes within our data platform. And these are really the issues that we were running into with our on-prem environment, SQL Server and SaaS. We needed a scalable data infrastructure. We didn't have unlimited horizontal capacity to continue to expand out. So our pipelines were serial. We had this one and done type mentality. Certainly when we ran into problems with full cube rebuilds, and those taking 10+ hours to run, if that failed, we would basically be out of the water for half a day at least. Most of the day usually. And so what that does is that going upstream, it puts constraints on the entire upstream system, and the data changing there is not frequently loaded. So we got latency, we got missing data because of the way we run our build process with the cubes. We deal with a lot of semi-structured data, and all the ingest from the internet, from gateways and brokers out there of our data feeds are usually JSON, and we would load those onto a SQL Server box and then run some PowerShell scripts to really flatten stuff out, and then load it as structured data into SQL Server, and really kind of painful process. So we needed to kind of flip the script there and go to schema on read. And so this is what Snowflake really gave us that we really love. And so we're able to ingest data directly and then start reading from a variant, and as opposed to trying to manage all that within a single node, trying to flatten everything out. And I'll cover that more in a little bit and the problems we had there. And so number 3, data movement constraints. Really, this was the big one that caused a lot of pain for us in maintenance. Cube builds being fragile with that much data, trying to physically move it from one box to another. You have physics that apply, and issues would arise, and then those issues just would continue to the next day and cause basically an outage and lack of data visibility to our business. And our business is online only, right? So they're completely dependent on our data to find out how their tests are running, how the products are doing. So it's not a good situation for us to be in. And loose coupling. That's what we really needed to get to. Right now, all the cubes and SQL Server, 2 physical boxes. All the cubes were on a single CPU or a single node with multiple CPUs, but essentially tied to the same resources and limits. And so when we ran into lots of traffic, or Monday mornings where everybody's trying to find out how the deals and how sales were over the weekend, you run into these issues where you get bad user experience and performance issues, and we had no flexibility there. Number 5, for agility and speed, we were lacking the ability to really iterate and move quickly in a presentation layer. Something that would take hours to build a cube and model it and deploy it. wasn't acceptable. We've got a very sharp development group. The data team has the ability to move fast, but the tools were dragging us down. So that was really something we needed to break through there. And number 6, the mission we're on, self-service analytics and extensibility. We're a very, very small team. 4 people working on ingestion, data pipelines, data analysis. We've got to enable the rest of the companies. We've got almost 150 employees at Slickdeals. We need to enable them to provide themselves the answers they need and to be able to iterate through. And so what you'll see later is how we've been able to achieve that with AtScale and enabled extensibility for our power users with the product. And then just in general, our data volume growth. We've got a lot of potential data opportunities with Slickdeals, and on-prem, we just have physical limitations. So we really needed to get to a place where we've got unlimited storage and we can grow with the business and the demands they have. And that's about it for the barriers. So let's just go ahead and jump right into kind of what the year of change and how it worked. So in this slide here, you'll see what our basic default ingestion pattern was for processing data and ingesting on-prem and then getting it into a SaaS cube. So the situation arrived early last year where we were starting to bring on Blueshift as our new SaaS email marketing system, and essentially just ran into volume and velocity problems. The data was bigger and faster than we were able to process through PowerShell. And so this would include deal alerts, which is how we notify folks of special deals that you put rules into the system for, newsletters and recommendation emails and things like that. And so we're sending hundreds of thousands to millions of these a day, depending on the time of the year. And very critical to get them out into Blueshift or through the system to our users and customers. But then we're also trying to do reporting on that data, and that's all being fed to an S3 bucket in AWS. And so we're pulling that bucket and storing those files on a file system somewhere, and then trying to run some PowerShell on it and parse through JSON, and essentially just couldn't keep up with the demand. And so after about three days or so of trying that, working with Kyle and the team, trying to figure out, well, what do we do here? Because this is obviously we're not going to catch up. And so we had to pivot at this point. So that's really when we took the leap to the cloud. And so this is our first iteration of the changes with where we included Snowflake. This was pretty fast. We got into this only a couple weeks into the pilot. And as you can see, it may not make so much sense from the arrows, but we kept kind of the initial download pattern. And then we started pushing things back up into Snowflake. And we really had to prove that we were going to use Snowflake and understand the technology and really leverage it the way we could. So we didn't change a whole bunch right away. But you can see that once we did that, we basically turned our parsing problem into something that could be solved in minutes as opposed to days. And so we were all very happy about really getting over that hurdle. And it made a lot more sense because the ability to just store the JSON directly in Snowflake. And so we, after a while, we continued with the building the pipelines this way, and then we added this the WhereSate Snowflake adapter to help us out too. And we were loading Snowflake, trying to figure out what the next steps were, because traditionally our users are used to cubes and getting that good experience that they're used to with being able to drag and drop dimensions and metrics onto a canvas, right? Using Tableau or Excel, we were looking for a solution within the new environment in the cloud, and how are we going to still solve that problem. and get to where we wanted to be. So there is no OLAP in this picture. So what we built was a Tableau dashboard that connected directly to Snowflake for email, just for our email users, because we were really focused on building this email product at this point. And put together a great dashboard, but Tiffany did an awesome job on my team, and it's a really slick dashboard. Problem was we had to do all the modeling, and you basically have to know SQL inside of Tableau to make this thing work. And so that really didn't lend itself well to the thought workers, the product managers, the engineers, or content folks that want to get access to their data. That wasn't going to work for them. So we searched around. We toyed with a DIY approach, kind of build our own graph DB. We looked at several visualization tools. We talked about trying to build AGs manually, but really there's only 5 of us, including myself, and I'm not really helping out with not that much. So just we couldn't achieve real self-service in the way that we had it previously with SQL Server Analysis Studio. So then we went searching for our common semantic layer and that single source of the truth that can serve multiple BI tools. And so this is the current view of our system. And as you can see here, we've added AtScale. We've got Snowflake still in the middle as our backend system. We've got Snowpipe connected to some S3 buckets within our own S3 environment now. So we're actually storing our own inbound landing zone for events that come through S3, and then we process those in via Snowpipe. And then we've also introduced Kafka here, in which we're starting to publish events out to the bus and start ingesting those into Snowflake also. And what you can see here is that really all of our data is flowing into AWS here and into Snowflake, and then we're bringing more data from other cloud providers into Snowflake in the same fashion. While we are building, or we've got the engineered aggregates that are being processed in Snowflake, and then we're really just bringing those ags back into AtScale. So we're avoiding the egress problem with this hybrid approach, because we've got AtScale on-prem. It works really nice for us, and so we're able to control cost with the egress and movement of all that data, plus the engineer aggregates really just totally help us, because we don't really know what the users are going to ask of the data, and we can't know that across the board for all of our users. So this is very, very helpful for us and makes us much more productive. And so essentially this is what the email cube product was. And yeah, let's keep going, and I'll kind of show you the behind the scenes and what we've done in the Snowflake side to help with our agility and our loose coupling to get the flexibility we wanted to. Is that the team is dedicated, they're extra small warehouses right now, but they've dedicated warehouses for each of our cubes and each of our processing layers. So we have complete decoupling from our presentation layer in AtScale, and processing on the back end for the different components, whether it's like load or stage, and then all of our cube processing. So depending on how many users we bring onto that cube or how active it is, we can spin that up and get more capacity to really improve the user experience, especially like on Monday mornings or after a big holiday in which everybody wants to know, how's revenue look, and number of outclicks, and how those campaigns ran. Let's go to the next slide. So after we tackled email, we tackled another kind of problematic cube for us, which was the SEM search engine marketing cube. And so this was our big milestone here, I think, and then we've proved out quite a bit with this one. Essentially, Ryan on our team just developed and deployed UAT this whole cube, all the pipelines within a month, which was really unheard of compared to where we were before. We got multiple attribution models included, new metrics and functionality. Data freshness really is no longer a problem because we can get that data into Snowflake and then issue continuous rebuilds pretty quickly. There's no more long waits to deploy a model, and the ability to deploy and test models quickly really helps the team move faster. And as you can see here with our bridge table, is that in that decoupling is that we can design the model the way we want and actually have the physical layer look different. And so that gives us much desired flexibility like we want. And if you go to the next slide, you'll see really kind of the entire model there for the search engine marketing cube. And it's been a big win. We've brought our marketing folks on it. They love the cube, and they've actually extended the cube too. So they've actually done their own deployment. And what we've done is that we just do before they do deploy, we do a backup of the existing cube, and so we can roll back really quickly. And so this is the goal that we want to push throughout the organization for all the remaining cubes. And next, the one that's currently in flight is our loyalty and extension cube, and the next big one after that is our universal cube, and we're hoping to be done by the end of 2021 and retire SaaS. As far as Snowflake goes, Snowflake migration is in progress right now, and kind of in dual production mode with SQL Server. And so we're taking our time and refactoring all the pipelines for our event-driven architecture so that we can really bring fresher data in faster, less latent to meet our needs of the business. And that's about where we're at for last year. So very successful.
Wow. Thanks, Greg. Hi, everybody. This is Dave Mariani. It's really stunning that, with 4 people, with a team of 4 and yourself, that you're able to support a business that's generating, billions of transactions and saving, $6 billion for consumers. That's amazing. And it really sort of highlights that, that you like the kind of leverage you created. You had to create leverage to actually make it all work with just 4 people, right?
Exactly. Yeah. We were forced to make a change, and we made the right change.
So thanks a lot for all that. What I'm going to do now is just is talk a little bit about some of the ways that Greg and Slickdeals went through the same process that I'm going to sort of highlight for you and really give you show you some real life examples of just the pros and cons and the different methods for how you can take a dimensional workload into the cloud. Because you could see that, right, trying to create a self-service architecture like Greg did, with a team of 4, you can't be out there building Tableau reports for everybody. And you also, I'll show you, what the downside is to having the business build their own Tableau reports. But having a dimensional semantic layer and allowing your customers to self-serve is really a great way to create the kind of scale that Greg got. So why do we even care about this? Like, what was it that was so important about SSAS that kept Greg wanting to come back to it? Well, because of these real 3 big things. SSAS is really fast, and it's fast in that it is speed of thought fast. It's not in today's cloud world. A lot of people have gotten used to queries coming back in 10, 20, 30 seconds, even minutes. That's really a throwback. And people should be able to and analysts should be able to ask the next question once they've got the answer to the previous one. And that's really important. What SSAS did also for Greg and for other customers is it creates that single semantic layer, that single source of truth. And that's like really, that's obviously critical to have everybody speaking the same language and to hide some of that complexity of where all that data is. You saw with Greg's architecture how much that's changed. And that change was really hidden from those users, even though Greg had to scale the physical hardware. Really the data interface didn't change. And then, of course, doing things like attribution, that's not for the faint of heart. And Greg's team knows what the data is, how it's structured or not structured, and then how to turn that into consumable analytics. And doing that with a dimensional approach is going to be something that is obviously superior than asking the business to try to reconstruct that for themselves. So really, there's sort of three approaches to doing dimensional analytics in the cloud. Greg has, started out, and a lot of our customers have started out on SSAS. When I was at Yahoo, I was on SSAS. And that largest cube in the world at 24 terabytes was a crazy cube, but I just couldn't keep it running. I loved everything that I just talked about the speed, about that semantic layer, and about the business expressiveness of that calculation engine, but I hated the scale and I hated the architecture. So that's still available today. You can do that on-prem, and of course it's offered in Azure as well, but with really a lot of the same problems. Now DIY, Greg tried the DIY a little bit himself. He kind of went through that journey and kind of came back to wanting to have that dimensional model. But yeah, you can sort of abandon dimensional analytics altogether and build those reports and dashboards directly on your cloud data warehouse. And there's drawbacks to that, and we'll cover that in a second. And the third approach is to what I call a universal semantic layer. Decouple the universal semantic layer from the actual cube and the storage layer. And that is creating a universal semantic layer that will sit on top of your data stores, whether they're in the cloud, on-prem, or still in the data lake. And so you can have your cake and eat it too. So the way this looks, you saw that, Greg kind of looked like this. Of course, he was using Excel and Tableau. That's great if you can talk straight to analysis services. Sometimes if you have to go back and get the raw data, you got to bypass that OLAP cube because either it's not fresh enough or it doesn't have all the detail that you need to answer your question. But it's a pretty good solution. The DIY is saying, hey, it's a free-for-all. Everybody is going to go and serve themselves. And when they serve themselves, you can guarantee that the reports in Tableau versus the analysis that are done in Excel, in Greg's case, are going to look very different because people are going to be calculating metrics their own way. They're going to have different access rights to get to that cloud data warehouse, and they're going to have different performance characteristics. So the universal semantic layer or a unified data model does sort of the best of both worlds. So it gives you access to directly the cloud and the cloud data warehouse, allows you to support all those tools, but get a single view of that data. So, so you're not restricted by size, you're not restricted by scale, and the data stays here. So as you saw, as Greg moved along the timeline, you saw that the data warehouse and the cubing layer were growing and scaling separately. And that's a problem. You want to be able to scale your cloud data warehouse or your data warehouse and not have to worry about scaling your semantic layer. So that's one of the benefits of this approach, is that when moving to the cloud, you don't have to worry about scale anymore on your data warehouse. So that's even great. That's even better. And you should be demanding the same thing for your business intelligence engine. It shouldn't have to scale itself. It should scale with your data. So what are the pros and cons of the different approaches? Look, SSAS, I love it. I love it. I love the fact that I can do direct connect through Excel. I can do, I have that semantic layer, it's fast. What do I hate about it? I hate that I have to load it. I have to calculate that cube. Greg's cube took 10 hours to calculate. Mine at Yahoo took 7 days to calculate. So it was crazy amount of time to actually get that view. What's great though is it's fast and it handles these complex interactions and business calculations. On the DIY front, hey, look, it's great to have, your users have unlimited self-service. They can go and do anything they want. Now, there's always a bad side to that, of course, is that the users can do anything they want, which means if you want to govern it, if you want to make sure people are not seeing PII or not seeing sensitive data, you got to be really, really careful, and there's going to be an accident. It's also tying direct access to your cloud data warehouse means that those schemas are frozen. So Greg has changed his schemas multiple times as the business changes. If now the users and the consumers of those BI tools have to also understand how that data is changing, now you have a whole organization that has to understand the data infrastructure for the company. And that's just not efficient. The business line people should be doing business. They shouldn't be doing data engineering. So, so really what I'm going to show you here is really a big difference between a DIY approach versus a universal semantic layer approach. And so for the demo, of course, I'm going to be using AtScale as that universal semantic layer. I'm going to be talking to Snowflake, and I'm going to be using a variety of BI tools. So so let's go and see. Let's go and see. I'm gonna move to my my Windows environment, and I'm gonna log in as Joe Average. So I'm Average Joe, and I'm gonna log in to my Windows environment. So this is important, right? Because right now I'm in my Windows environment, and it knows I'm Joe. And here I have my Power BI desktop already loaded up. And I'm going to go ahead and connect to Snowflake. So this is the DIY approach. I'm going to come into Power BI, which is a great tool. I'm going to go and use the database driver. They have a connector already for Snowflake, and I'm going to go ahead and connect to that. Okay, so what am I going to see here? Okay, this is my connection screen. And in my connection screen, let me go get my connection here. This is my Snowflake instance. Okay, and I'm going to paste that in there. Now, problem number one, I have to specify the warehouse. Now, if you know at all Snowflake, you're gonna let the user, meaning the consumer of this workbook that's creating this Power BI workbook, is going to be specifying their own data warehouse size. In this particular case, I'm choosing a 3XL, which is a pretty expensive data warehouse. So that is now going to be embedded into every report that I'm about to build in this workbook, which means I'm going to be using a 3XL Snowflake data warehouse every time, regardless of whether I need it or not. It's going to be spun up. That's a problem. The second problem, which is much more subtle, but you notice that this radio button is highlighted on import. So most BI tools, including Tableau and including Power BI, want you to import the data, extract it into their own engine. That's a problem because now you're creating a whole nother data store, you're creating more data movement, and you're obviously going to have to scale down what you look at. Well, I'm not going to do that. I'm going to choose direct query instead for Snowflake. And that's because I want a live connection to my data warehouse. I don't want to have to import and create static data. Okay, so what it's doing now is I'm connecting to my Snowflake instance. And problem number 3 is that I get access to all this data. You know what? I probably shouldn't have access to all this data. I see poor old Caleb has got his tables there. We got all kinds of different sort of stuff going on here. And then look at all the different schemas I have. If you have a data warehouse, it's going to get complicated. So now I have to find the tables that I want. So for today's demo, what I'm going to be doing is I simply want to look at my sales by country. This is the most simple use case you can imagine, right? So I happen to know that my sales are in my sales log table. So there I have it, and there's my sales. That's good. But I also want to look at it by country. So I got to find my dimension table that has my country lookup. And let's see if I can find it here. Well, I have a bunch of dimensions. I said I want to have countries, so I'm going to select that. And there's my countries. And I'm going to click load. So now what Power BI is doing, it's making a direct query, not as Joe Average. It's going to be doing a query with using my credentials that I put in. And it's now logging in and getting data from that sales log and the geography country dimension that I think I'm going to want to use. Now, of course, it's got to load this into analysis services. Well, it's loading into Power BI. Power BI behind the scenes uses analysis services as the engine. So it's kind of it's embedded in here. And so it's still loading. And this is just for 2 tables. Okay, looks like we're getting close here to me running my first query. If you're if you're an analyst like me, this would drive you crazy. Is it just to be able to explore? I'm not kidding around here. We're still running, and this is on a 3XL just to be able to get my data. Still working on it. Okay, here we go. Okay, here's my data over here, and I see my sales log, so that's good. And I'm going to choose my sales amount. So that's going to be the amount of sales, of course, that I sold. And so it's going to run that query. And then I'm also going to go and choose to do it by country. So I'm going to click on country. And so that seems simple enough, right? I did sales by country. So let's just look and see what my results were. Let me make it bigger for you. Well, that's obviously not right. There's no way that I can be selling everything and $46 billion across, every single country. So why did that happen? That happened, if I go to the data model tab here, it happened because I didn't connect my sales information to my geography dimension. And you may say, well, that's dumb. You should have known how to do that. Well, that's a user. I just ran a Cartesian product on my Snowflake data warehouse, meaning it did everything by everything. And if I did this with large data, it would bring that Snowflake instance to its knees. So that was wrong because I have to model the data myself. So now in Power BI, I have to understand how this model is constructed. So what am I going to do? Well, I'm going to need to connect up country. I don't have any way to connect country because this is all the data I have. It turns out that I have to first connect to the country of where the sales happened through my customer, because my customer has their address. And how do I do that? I don't know. I would have to go talk to IT or take a lesson on how our data is structured to understand that. So that's not a great approach. So let's go and see a better approach, and let's go create a semantic layer. So I'm going to pop to AtScale, and this is what we call Design Center, and this is what we call our canvas. So I've created a model, and over here you see I have dimensions and measures for this particular model. So instead of so what I'm going to do in Design Center is I'm going to create a new virtual cube, and I'm going to call it Sales Insights. And it's going to be called Greg, because Greg is our guest of honor. So I've created a virtual cube, and now I'm going to go into my canvas. So here's what's really important. So I'm going to define this business model. You can see I have a couple data warehouses here, and I'm going to define it. I'm connected still directly to Salesforce, to Snowflake. And I'm going to go and I'm going to select that sales log table here and pull it onto my canvas. So, so here's my sales information. I'll go ahead and pull it on. So what's important here is that this is my data now, and this is the same data you saw in Power BI. The difference here is that I have the ability to use a library of the conformed dimensions. So rather than me having to understand how to join all that data together, I can simply pull in a date dimension, I can pull in a product dimension, and I can pull in that customer dimension. Now, in order to hook all this up, all I need to do is to wire them up and create what we call a relationship. So I have my product key and I connect it to my product key just by connecting a line. So then what just happened there? What happened is that you can see that in my semantic layer, I automatically got my product subcategory, and then I got a hierarchy of my products. And I got that for free because this dimension has been shared and defined once, and now I can use it many times. Let's do the same thing with customer and see what happens. So I connected customer, and now I have a bunch of customer information, including my geography. And there's my country and state. So I automatically got that for free because that customer dimension contains its own geography dimension. That geography dimension is actually made up of multiple data sets and also what we call a security dimension. So now Joe Average is only going to see what he can see in the Americas. Okay, so let's keep going back and let's finish off this process, because what I also want to do, it's no good if I can't report on time. So I'm going to go ahead and I'm going to drop in my order date, and I'm going to put in a prefix called order, and I'm going to drag in my my ship date and do the same thing there. And now I have not just the customer dimensions of products, now I have all my hierarchies automatically showing up for my date dimension. So I'm not done yet. I need to do a couple measures. I want to definitely look at sales. I'm going to put it into a sales metrics folder. I probably want to look at how many products were bought. I'll put that also in a sales metrics folder. And voila, if I look at preview, now I have my semantic layer right there. So all I need to do now is to publish this, and I'm going to publish this. Now, all the rules for what Joe Average should see are already have been defined in that customer dimension. So now Joe Average, because I set up my security in this semantic layer, and because I set up a group for my Americas, and because I assigned Joe Average to only see the Americas data, that means anything I do in whatever BI tool I choose is going to be restricted. Joe will only be able to see what he should see. So let's come back here and let's do it the AtScale way. So the AtScale way is very much like you're used to doing with analysis services. So AtScale looks to Power BI and to Excel just like analysis services. So what I'm going to do is when I go ahead and get my data is I'm going to choose the analysis services built-in connector here. So, and I just choose the AtScale server right here. And look at this. It's highlighted on Connect Live. So I'm now connecting live. I'm not importing data. And I get to see now, there's my project. There's the Sales Insights Greg cube that I just defined. So in really literally a few minutes, I've defined a universal semantic layer now, and there's all my data. So there's my data, but it's rich this time. So now I got my sales information. You see I have nice folders. You can see I can go ahead and run my query against sales amounts. You can see that I also have my order dates, and then there's my geography dimension. So there's my geography dimension, and in my geography dimension, I have multiple hierarchies. So I'm going to go ahead and choose the city hierarchy. And if I look at what happens over here in my window, what I have is I have just what Joe Average can see. Joe can see United States and Canada because those are the Americas. Now, the other thing that's interesting is you look what's happened. You can see that because I have a hierarchy, because I have a dimensional model, besides having very nice, easy to read and organized metadata, I can now do great things like, you know what, let's do include only the United States. And let's filter on United States, and let's drill down on United States to my country, and to my country level, sorry, and to my state level. And there I have my California, and let's go and keep that. And then let's go ahead and keep drilling down and drill down all the way to my cities. And I'll change my my visualization so I can see it better. I'll change it to a table, and there's all my cities for in all my sales by cities. So I got the right data. It didn't do a Cartesian product. It did the right thing. Why? And why did it do the right thing? Because if I click on this model icon now, what you see is that the model came along, the at-scale model, that single semantic layer, all that relationships that I just created for you, that all comes with the connection. That means there's no way that people are going to get different answers, or people are going to get wrong data, or people are going to have to redo this model. It comes for free, and all they have to do is pick and choose the metrics and the filters that they want to create their visualizations. So what happens in Excel? In Excel, it's the same thing. So again, because we've chosen a universal semantic layer that is compatible with analysis services, you can have your cake and you can eat it too. So I can say, for example, let's go ahead and get some external data from Excel, if it will allow me. Let's do this. Here we go. I'll do other sources, and you can see analysis services is a choice. All I need to do is paste that in. I'm going to use my Windows authentication. So that means that I'm going to be logging in as Joe Average. So only data that Joe can see, he's going to see. There you see my Sales Insights Greg virtual cube I just created. And let's go ahead and just create a chart with it. And what you're going to see here is the same metadata that I just saw in Power BI. And so I can run that same query, this time in Excel with a live connection. This is not a data import. You can't do this by connecting directly to Snowflake. And now there's my same data that I got and I just saw in Power BI. And of course, because this is a direct connection, I can do great things by creating cells that directly reference cells in the AtScale virtual cube and build very sophisticated models without ever having to move data or without ever having to build or understand how to do data engineering and build a data model. So, so let's go back and let's just summarize kind of what we saw here in this case. Well, we saw a universal semantic layer. We saw all the best of SSAS in terms of the speed, in terms of the semantic layer, in terms of the MDX and DAX expressiveness. We saw the great things about how well it's integrated into the Microsoft stack, like Power BI and Excel. I don't have time to show you Tableau, but it works great for Tableau as well. But it really makes data analytics ready and easy to use. And it promotes that consistency. So everybody's going to be speaking the same language because the definition of attribution in Greg's case is going to be the same regardless of whether they're consuming with Tableau or with Excel in Greg's case. You drive that agility. So someone like a team of Greg or even users themselves can create those models and really get leverage out of reusing the dimensions and reusing the different objects in that semantic layer so that they are able to create new views very quickly without creating a bunch of extra work. And you saw that me as Joe Average, I only saw half of the data. I only saw the data that I was supposed to see. And those definitions, that governance was built into that customer dimension. So regardless of who's defining these virtual cubes, that definition, those rules are embedded. And there's no way that Joe Average is ever going to see anything in any type of combination outside of what he's supposed to see. And if everybody's speaking the same language, if everybody's working off the same data, in this case in Snowflake, they're going to trust the analysis and they're going to trust the output. And that's what you really need to do at the end of the day. So, Laurel, I'll hand that back to you to see if you have any questions or anything further that we want to cover.
Great. Dave and Greg, thank you both so much. Super interesting as usual. And that was very thorough, but I do have one question, Greg, that came in during your part of the presentation that I'm going to pass over to you, asking if you are loading data directly into Snowflake or having Snowflake look at your S3 bucket. So basically, are you using Snowflake for querying and data access?
Yeah, we're loading it into Snowflake. So we'll keep a copy in S3, and then that case, kind of an offline raw version of it. But we're loading everything in.
Excellent.
Yeah, that's actually, Laurel, that's kind of a good question. I just want to go back to a previous slide. Just what Greg is doing in looking at this is he's loading his data from S3 into Snowflake, which is a data warehouse. Now, that's probably the preferred pattern because he's going to be doing whatever kind of scrubbing and normalization there. You can, through an engine like Spark, for example, or Amazon Athena, you could connect with AtScale straight through to the S3 buckets if you wanted to, and expose those the same way. So the universal semantic layer is more than just access to a data warehouse like Snowflake. Of course, we can access traditional databases as well as access the data lake directly. So Greg isn't doing that yet, and may not want to do that, but that's just another option.
Thank you
Anything
for
else,
that
Laurel?
explanation. That about wraps it up for questions that weren't covered. Everybody who's attending, again, you will get a recording of this webinar. And if you have questions that come up, you can contact us through our website or email us directly at hi@atscale.com, and we'll make sure that we get back to you with the information. So again, Dave and Greg, thank you so much for another super interesting webinar as usual. Thanks for attending, everyone who did. And again, there will be a short survey on your screen once this ends, and we'd really appreciate it if you could just let us know what you thought about this and how we can produce content that you'd like to see going forward. So thanks, everybody.
Thanks, Greg, and thanks everybody for listening.
Thank you, Dave and Laurel. Bye-bye.